Hello everyone, welcome to our channel Codus Arcade. In this section, we are going to learn about a very important topic in C language, which is recursion. Before starting the video, I would like to request you people to please like and share our videos with your friends and family, and at the same time, subscribe to our channel Codus Arcade and press the bell icon if you like our videos. Thank you. So let's get started. Today's topic is recursion. So let us move on to the definition of recursion. Recursion means a function calling itself is called a recursive function or recursion. In simple words, calling a function from the definition of the same function is called recursion or a recursive function. For example, we have the main function, then inside the main function, I will use the first print statement where I will write start. Now I want to call the main function explicitly. For the first time, the main function is called by the operating system or the OS. Second time, I will be calling it. So you can see here, inside the main function, after the first print statement, where I've written start, I'm calling my main function explicitly. Next, I'm going to add one more statement. So after the main function call, again I'm going to write my third statement, which is print end. So this is a basic example. Here you can see that we have two print statements which print the messages start and end. And in between we have explicitly called the main function. Now let's see how it gets executed. In general, to execute functions in the application inside the RAM, a memory will be allocated. This memory is called the stack memory. I am not talking only about C language. In any programming language, stack memory is common and any function or any block of code is always executed inside the stack memory. In order to execute a method or a block of code, some amount of memory will be allocated inside the stack memory. This particular amount of memory is called frame. So for the first time, when we are executing this program, operating system invokes the main method. So some memory will be allocated to this main method. Here, one main frame will be created and a certain amount of memory will be allocated in order to execute all the three statements defined inside the main method. First, it will print the start message. In the second statement, we are calling the main method explicitly. Therefore, in order to execute this main method, one more frame will be created. Now, inside this main frame, all the three statements should be executed. So let's start again. The first statement is print start. Again, in the second statement, the main method is called explicitly. So another main frame will be created. Similarly, here also the same process will continue. It will print start. Again, we are calling the main method explicitly. So again, one more main frame will be created. If you observe carefully, every time this program is moving in the forward direction only. Once all the three statements have been executed, then the frame will be deleted and the memory will be assigned or allocated to some other method execution. But in this case, or in this example, every time the control is moving in the forward direction only. So there is no chance for the control to come back and complete the execution of the previous frame. Therefore, there will come a time when the memory will be full and the program execution will encounter an error called the runtime error and it will be showing out of memory. So our program will terminate abnormally because there is not enough memory in the stack to continue and to complete this program execution process. Therefore, the most important thing that we should keep in mind while working with recursions is that we should be careful while writing the logic of the program, because the order in which the control is going forward, it should similarly come back and end the process where the execution process started. Therefore, we should follow that format while writing the logic of the programs for recursions. The best example to explain recursive functions is factorial of a number using recursion. Let us go to the editor so that I can show you how to write a C program to calculate factorial of a given number using recursion. After the execution, we will come back and see how the program execution occurs. So let's quickly move on to our editor. As you can see here, I am inside my editor screen, which is code blocks. So let me start by including the header file. And here I will take my main function of the integer data type. And inside the main function, I will start by writing the logic. So first I will take a variable n for the count, and then I will take another variable to store the result. Now I will use the print statement so that I can ask the user the value of n. Then I will use the scanf function to read the input from the user. So it will be %d address of the variable n. So this thing is done. Here I will take the result variable and I will call the factorial method, which I have to define outside of the main function. Factorial of n. So this is also done. After that, we will be printing the result. The factorial of %d is %d, comma, then for the first %d it will be the variable n, and for the second %d it will be the results variable. So this is also done, and just because it is and just because this function is returning integer values, I have to give return 0. So now this thing is done. Now let us go on to the function definition. So here it will be the same thing, integer data type, then it will be factorial as I have written here. As you can see here, factorial, so it should match factorial, and then I have to take the variable which is integer and it int n. The variable can be same no matter what, it doesn't clash, it's upon your wish, no problem. So now let us go on to the definition of the function. So here it will be int result, and now the first condition is, in factorials we know that the factorial of 0 is 1. So we will use the if statement, n equal 0, then the result will be is equal to 1. Now we will go on to the else block. If the value of n is not equal to 0, then we will start the else block. So inside the else block, we will use the actual formula for the factorial of a number. So the formula is result is equal to n into factorial n minus 1. And after that, the final thing that we have to do is we have to return the result. So with this, the logic of the program is complete. Now the question is that why is this called a recursive function? As I told, the definition of recursion is that a function calling itself is called a recursion or a recursive function. Therefore, as you can see here, inside the function definition of factorial, I am again calling my factorial method. So inside the same definition of factorial, I am calling my factorial function or method. Therefore, this is called a recursion. So I hope you have understood this. Now let us look at the execution process, how this factorial will actually execute itself. Let's see that. So now let's see how the method spaces are created, how the control will go in a forward direction, and how it will again come back. So first, the memory will be allocated to mainframe. So the starting frame will be the mainframe. We are declaring the n value and we are declaring one more variable result and then we are reading the value of n. In the next step, we are calling the factorial method. Suppose let us take the value of n to be equal to 4. So it will be factorial of 4. The result will not be assigned. First, factorial of 4 method has to get completed and executed. So method space will be allocated to factorial of n value 4. Then the factorial method execution will start. First, if n equal 0 or 4 equal 0, as you can see condition is false. So the if block will not execute, control goes to the else block. In the else block, n into factorial of n minus 1 executes. So 4 into factorial of n minus 1, that is 3. Now to multiply this expression, first we have to know the value of factorial 3. So one new method space will be created for factorial n equal to 3. Here if 3 equal 0 and we see that the condition is false, so in this case also if block will not execute. Control goes to the else block. In the else block it is 3 into factorial of n minus 1, that is 2. Again we should find what is the value of factorial 2. So one new method space will be created for factorial n equal to 2. Now if 2 equal 0, here also the condition is false. So the if block will not execute. Control goes to the else block. In the else block it is 2 into factorial of 1. Again we have to find what is the value of factorial 1. So one new method space will be created for factorial n equal to 1. Now if 1 equal 0, here also the condition is false. So if block will not execute. Control goes to the else block. In the else block it is 1 into factorial of 0. Now one last method space will be created for factorial n equal to 0. Now you have to observe carefully. If 0 equal 0, here the condition is true. Now else block will not execute. In all the previous method spaces, we have seen that the else block was executed and the if block was terminated. But in this case, if block will execute and the else block will be terminated. So in the if block, result equal to 1. That means in the result variable, the value 1 will be stored. After the if else statement, what is the next statement? Here we are returning the result. So return 1, which is the value of result. The value of result here is 1. So the value 1 will return back here, as you can see on the screen, because the factorial 0 function started executing from this position. So result of the factorial 0 function will return back to the same place. So 1 into 1, therefore result equal to 1. So again this result will return back here. So 2 into 1 and now result equal to 2. So again this result value will return back here, as you can see on the screen. So now 3 into 2, that is result is equal to 6. So again this result will return back here. So 4 into 6. Now the result value is equal to 24, as you can see here. So this result will be finally stored into main method result variable. So result equal to 24. And now we are printing this result, which is 24. This value 24 is actually the factorial of 4. So this is the end of the program execution. Now let us move on to our editor again so that I can show you the output of the program that we wrote earlier. So here, as you can see, I am inside my editor again. So this was the program that we wrote earlier. Now let me run it so that I can show you the output. I'm running it. And let me just zoom it for you. So here, let me take the value which we saw earlier. Let me take 4 and press enter. And you can see the factorial of 4 is 24. So we are getting the correct output. So let me press any key. So guys, this is the entire logic of the recursion topic, which is a very conceptual topic in functions, and the best example to learn about recursions is factorial. There are many more examples, but this is the best example with the help of which you can learn about recursions. So that's why I took this example to find out the factorial of a given number. I hope you like the video. If you have any doubts, you can post them in the comment section. I will be very happy to clarify those doubts. Thank you and happy learning. See you guys in the next video. Thank you.